Welcome everyone to this talk. When NDC reached out to us to give a training about threat modeling here yesterday, I see a few familiar faces in the room that attended my training yesterday and the day before that. So I was teaching a training about threat modeling, a basic introduction to threat modeling. I've had people in the room that were already very experienced at threat modeling. Did you still learn something about threat modeling yesterday?
Yes.
You did? Okay, that's always nice to hear.
Not doing well.
That's completely fine. We grow, we learn. So I was over here anyway to already give the training, and then NDC asked, as a trainer, would you be willing to give a talk about any topic that you are passionate about? So I turned the challenge around and I told NDC, like, you give me a topic and I'll then talk about that topic. And this was then, after a few brainstorming sessions, what we came up with. When it comes to threat modeling, if you're not absolutely clear on what threat modeling is, I will give you a very, very short recap on what we perceive as what is threat modeling in the first place. There are a lot of opinions on when to start threat modeling, and that's quite popularized already of when to start threat modeling. When is it too early to start threat modeling? When is it too late? There's a lot of debate about that, but nobody really talks about when have we done a good enough job and when do we need to stop threat modeling. So that was, I thought, a very interesting topic that I constructed a conference talk about, and that is what I am going to be talking about to you today. This talk will also serve as kind of an ask me anything about threat modeling. So I've already said the word threat modeling about 10 times. You probably figured out that that's my job. I am a threat modeler. That's also my title on LinkedIn. I'm not going to read you through my entire resume over here. You can see that on LinkedIn. This QR code is not a phishing test, I promise. You are free to connect with me on LinkedIn if you will. What I do is I build threat models for very complicated systems. So most of my clients are in the atmosphere of very high-stakes medical devices, pan-European electricity provision, government systems that have been already active for a few decades that now are facing new cyber threats. So those are the kind of systems that I threat model as a job. I also work as an educator. I think it's really important that we, as cybersecurity professionals, help other people also understand what we are doing and what we are expecting of them. Because universities and colleges don't really incorporate cybersecurity into IT programs. In other parts of the world, that works better, but here in Western Europe, that's not really a thing. So I also make a point out of helping college professors and university professors to give guest lectures at educational institutions. First, to get everyone on the same page of what threat modeling is, this is one of the formal definitions of what threat modeling is. I'm going to be quiet for 10 seconds to let you absorb this and read this. An important distinction between threat modeling and penetration testing is that threat modeling is about analyzing representations of a system. When you're analyzing a system, then you are penetration testing it, because when you are threat modeling, in an ideal world, you are looking at the architecture of a system. You're not looking at the system itself. Also in an ideal world, and this goes into when to start threat modeling, in a very, very ideal world, you can look at the architecture of a system before it has even been built. Or you can look at a feature change of a system before it has actually been implemented. And then there is a lot you can still do to change the way it works without having to throw a lot of code away. Developers are very high in demand. They are very talented people, they are very creative people, and you would like those people to spend their time on doing useful things. Time and time again, I talk to developers who are a little bit allergic to the security department because they are the department of no, and you should have done it differently. And then developers very rightfully say, why couldn't you thought of this before? Now we are already 6 months into development, and now you start showing up with security requirements. We would have appreciated you telling us maybe a little bit sooner before we started coding all of this up. And that is literally the purpose that threat modeling solves or serves in that regard. Architectural risk analysis is also one of those terminologies that you might see floating around. Cyber FMEAs. Is anyone of you familiar with the abbreviation FMEA? Very few. Fault mode effects analysis is one of those things that in aviation and medicine is used a lot. So you're starting to look at, with a medical device, for example, you're starting to look at, okay, we have an injector robot. What can go wrong with that injector robot? If the battery runs out when the needle is in the patient, what happens then? Maybe we should assess the battery level before we plunge the needle in. That's something that you can then get out of a functional FMEA. A cyber FMEA is one of those FMEAs that purely focuses on cyber attacks. So that's also something that you could start using in your activities of threat modeling. When non-technical people ask me, okay, your job title is threat modeling, or you're a threat modeler, what does that exactly mean? How I explain it to lay people is when you watch the Ocean's 11 movies and you have a bunch of criminals standing around the blueprints of a bank looking at, okay, here is the safe and here are the doors and here are the windows. How can we get in? How can we achieve our goal of breaking into a bank? Breaking into the Louvre in Paris would have been a more fitting example, but I now had this slide, so I just stuck with it. So that is basically my job, but with IT architectures. I look at IT architectures and I look at how systems work and how I can break them, and then I talk to architects and developers on how to solve that. So that's a bit less of a techie approach, but that is what I do. When talking about threat modeling, you will very soon start seeing the 4-question framework pop up. The 4-question framework is a methodology of going through the different phases of threat modeling and then starting to wonder or ponder different questions. The first question of the 4-question framework is, what are we working on? Back in the day when the 4-question framework was invented, it was worded, what are we building? And that has been reworded, meanwhile, into what are we working on? Because what are we building very much breeds waterfall development. And as a software industry, we've really gotten very, very tired of waterfall development. In some industries, it still exists, or you have to, at least. We prefer not to. So what are we working on is a bit more of a fitting description, because threat modeling will, in an ideal world, also sprint together with your development teams. In every development sprint, you would ideally have the question, what are we working on? If the answer to that question is leveraging a change in your security architecture, then you might want to threat model that delta. That's a lot more of an agile way of threat modeling. Once you know what you're working on, I'm going to go 1 click back, getting the answer to the what are we working on question might seem like an easy to answer question. When you're talking to the people who are building the system, very often I find gaps in knowledge in the teams of how the system is actually working, what kind of components does it have. This is not always clear to everyone in the room what we're working on, but you have to go with the reality you have. The next question in the 4-question framework is, what can go wrong? Once we know what we are working on, we're going to assess what can go wrong with a specific type of system. The keynote talk was almost a threat modeling talk, because it was about how do we build AI systems and what can go wrong with AI systems. That's meta threat modeling kind of as a concept. Once you have an idea about what can go wrong, then you have to wonder, what are we going to do about it? And that question can have several answers. If your risk appetite is very high, if you are in a very, very competitive space, what are we going to do about it might be, we're going to write this down for later and we'll solve it when we get to it. That's an approach that you can take. A product owner will decide on this. This is not something that as a threat modeler you can start forcing. Of course, if the data processing that you're doing is turning into illegality, yeah, then you have to consult some lawyers on, do we want to get caught with this? But that's a different discussion. The fourth question of threat modeling kind of encompasses all of the previous three, and is, did we do a good enough job? And this is really what the topic of this talk is, because what is good enough? I often compare threat modeling with cleaning. When are you done cleaning? I mean, that kind of depends on the room I'm cleaning. If I'm cleaning my attic or if I'm cleaning my bathroom, my cleanliness standards will be a little bit different. So good enough is also very relative to what you are doing. A few things threat modeling is not. Threat modeling is not an all-encompassing security activity. Please do not think that when you hire a professional threat modeler that they will be able to find absolutely every issue in your system. In that regard, it's very similar to penetration testing. Penetration testing is also not all-encompassing. It's going to depend on the technical knowledge of your penetration tester, and it's going to depend on the time they have. Threat modeling is very similar to penetration testing in that regard. There's a lot of differences, but that's where you can see a similarity. Threat modeling is also not a replacement for other security activities. You can't say, we've made a threat model, hence, we don't need a firewall anymore. That's nonsense. We've made a threat modeler, so we don't need a penetration test anymore. That's also nonsense. It is a security activity in the whole landscape of security activities, but it's not the end-all, be-all of security activities. It's also not a one and done, as you say in English. Many people tend to think, sometimes when they start out in my training, when I ask people, what are your learning objectives, they are asking me, okay, I want to make a threat model, so then we have a threat model. The point of threat modeling is not to have a threat model. The point of threat modeling is to have a more secure product at the end. So just being able to tick the box, we've made a threat model, is really not the point here. It's just like penetration testing. If you want to have a penetration test done to be able to tick the box, we've done a penetration test, and then do nothing with the output, then you might as well spend your money elsewhere. So, now that we know what threat modeling is, and what it encompasses, and what it is, and what it is not, just to make sure we're all on the same page when to start threat modeling. So, 1 week before release, good idea? Probably not. It happens. I get a lot of consulting clients who come to me and who say, look, we are a security department, we take care of compliance, and we are struggling keeping up with the speed of development that our software engineers are putting out. And at the 11th hour, they're coming to us and they're asking us, oh, can you quickly do a threat model on this because we need to go live in days or weeks. That is not the way to treat threat modeling. There is...
The reason I did that was a validation, and that was independent brought in as a validation, to validate that the solution had been done correctly. So it was a validation exercise as distinct from...
Those are two distinctly different activities, but I have a slide about that. So that's coming up. Actually, this slide. So if you look at the OWASP SAM model, who of you is familiar with OWASP SAM? Show of hands. I see about 20% of the room's hand go up, so I'm going to explain a little bit what OWASP SAM is. OWASP, who of you has heard of OWASP? Maybe let's start with that. Okay, most people have. So the Open Worldwide Application Security Project advocates for developer-centric cybersecurity and puts out a lot of open source, anonymously consultable projects to help you with cybersecurity posture. The SAM project is the Software Assurance Maturity Model, which is a framework that you can use to measure the maturity of a software development team. It's a very, very useful tool if you are working with software engineering teams and you want to kind of know where are their strong spots and where are their weak spots. I'm not going to turn this into an OWASP SAM talk, it's just to give you a bit of an idea of where threat modeling fits in here. So in a nutshell, what SAM does, it looks at the 5 areas of software development. So governance, that's everything that's GRC, compliance, policies, training, all of that. Then you have everything that has to do with architecture. Then you have everything that has to do with development, you have everything that has to do with testing, and then you have everything that has to do with ops. And those 5 areas have distinct maturity traits to them. SAM is an interview framework that helps you measure how mature is this specific product team at cybersecurity. And then you can start putting roadmaps forward on how you think you should be moving to a higher level of maturity. No company on the planet gets a perfect score on this interview scale. Getting a 3 out of 3 in all areas is just overkill. You shouldn't want to do that. But there is something to be said about an increase in maturity in specific areas here. So when we're looking at architecture validation, this is not the right time to start threat modeling, because then you've already, as I've already explained, if it's just a matter of changing some blocks on a diagram, that's the right time to start threat modeling. So you actually need to start here. That's also literally why there is a threat modeling block here in the SAM model. Over here, you have architecture validation, and that is to your previous point. If that one is where you start threat modeling, no, this is where you validate whether the secure architecture that you've built based on a threat model or adjusted based on a threat model, that you've actually built what you've set out to build. This is something that we do see as software professionals. We see that systems slightly change from the architecture that we've designed. This is normal. When you start coding something up, you will have a slightly different appreciation, or you will have a different implementation method of doing something. If it changed the architecture, that might be fine, but you do need some kind of a cross-check over here. But Drake was not agreeing with the fact that we would start here. It starts here. Okay. So when do things start and when do things stop? That is not always very clear. So as you might have seen in my introduction slide, I studied mechanical engineering, so I was already into matrix multiplication before it was cool. So some things have a clear start and a clear end. That's in an ideal world, things have a clear start and a clear end. An example of that is a stand-up comedy show. Who of you enjoys stand-up comedy? Okay. These 3 people, you know what happens at a stand-up comedy show when you sit in the front row? No, I'm just kidding. I'm just kidding. That's why you don't like stand-up comedy, and that's why you feel safe sitting in the front row here. I'm just making a joke out of it, of course. But this is something very clear. So the host of the show says the name of the stand-up comedian, they walk on stage, they make a bunch of jokes, and then they say, "This was my time, thanks for listening," and then they go off the stage. That's very clear in when it starts and when it ends. Most things in life do not work like that. I've included a graphic here of, does anyone recognize what this thing is?
It's a Mobius.
Yes, a Möbius ring or a Möbius strip. It is one of those geometric shapes that doesn't have an inside nor an outside, which is weird to conceive, but it's very easy to construct. You just take a strip of paper and you paste it back together in the shape of a ring, but before you put the ends together, you flip one end over, and then you end up with a Möbius ring. So you can just trace your finger over the paper indefinitely and always go over all of the paper, both on the front and the back of this strip. So this is kind of the godfather of things that don't start and don't end. Human relationships tend to be a little bit hazy. When did our relationship start and when did it end? Some people have different ideas about what a relationship is in the first place, but this is, I think, a good real-world example of things that have a fuzzy start and a fuzzy end. So most things in life you can't really pinpoint to when does it start and when does it end. And this is also the difficulty with threat modeling. It is also one of those activities that you can say, like, okay, the first meeting we had with the words threat modeling in the meeting subject, that is when we started threat modeling, but that's actually not true. Humans are threat modeler. Every one of you is a threat modeler. Threat modeling lives in human nature. If you wouldn't all be threat modelers, there would not be a hotel here. The whole UK would be full of bamboo. The risk aversion that we have as humans makes us threat modelers. We think about things that go wrong. So species that have gone extinct, that's probably because they weren't very good threat modelers. Maybe we should think about it like that. This is Leonardo da Vinci, and he has a very famous quote saying that art is never finished, it's only abandoned. And this is how you also have to perceive any kind of activity. Also, those of you who are in software development, who of you is a developer, is your code ever finished? You can always make it better, right? The moment when you start writing code is maybe a little bit clearer than when you're absolutely finished. It's just when you stop typing, then it's finished. And that is the same with a lot of things on the planet. When you stop working on it, then it is in a state where you can decide this is good enough. That goes for code, that goes for painting, that goes for songwriting, and that goes for threat modeling as well. All of this was an interlude to what I'm actually going to offer you as solutions to the question of when to stop threat modeling. And the solutions I'm going to hand to you are not mutually exclusive, so you can kind of pick your own battles here. One of the most popular ways of limiting the amount of time you spend threat modeling, because you can just keep on threat modeling indefinitely, just like you can start improving, or you can keep on improving your code indefinitely. Reducing the scope by time boxing is a very popular approach. So you will just set out a specific amount of time, and when the time is up, then you just stop doing the thing. Again, my analogy with cleaning works very well. I am going to spend the whole afternoon cleaning my attic. And when my wife says that dinner's ready, then I've finished cleaning the attic because that's how far I got. This is something that is intuitively very, very natural to do. So time boxing can take various forms. You can say in every development sprint, we're going to spend 2 hours threat modeling. That might be an approach that you would take. If everybody knows that this is the case, you will also start focusing your efforts a little bit better. And this is where I think we've all been in meetings where the tempo of the meeting in the beginning was like, how was your weekend? Oh, traffic was horrible. Yeah, that's then the beginning of the meeting. And then the end of the meeting, you have to start rushing to get all of your topics in. Try to not do that anymore with any meeting, but also not with threat modeling activities. It's best to keep the pace. When we talk about the concept of trust boundaries, I'm not going to go into too much detail of what a trust boundary is, but when you look at systems and subsystems that interact with each other, when there is an interaction between 2 components, you have a data flow between those components, then you can say, if I trust one element differently or less or more than another element, then we have a trust boundary there. There's a transition of trust between those 2. So you can identify all of your trust boundaries in a system and then say, okay, for every trust boundary we've identified, we're going to spend 15 minutes. And then if you have a meeting of 2 hours, you would like to work your way through 8 trust boundaries, or at least have visited all of them. Another popular technique to reduce scope is by only focusing on specific doomsday scenarios. In the academic theory calls this n-scenario threat modeling. I found through experience that n equals 3 is a good way to focus your threat models. Less than 3 doomsday scenarios, so doomsday scenarios being the absolute worst thing that can happen to a system from a business impact perspective. So this is the Hindenburg. I think, I don't know if the Hindenburg was properly threat modeled. Apparently not. Accidents still happen, of course, but the doomsday scenario setting is really about what's the worst that could happen. So you set a doomsday scenario from a business perspective. You're not looking at likelihood, you're just looking at impact. The absolute worst impact is then, if you look at it from an attack tree standpoint, So if you've never seen an attack tree, this is an academic example of an attack tree. The absolute worst thing to happen is listed here at the top. And then everything that would need to happen before that, that would need to happen before that, that happens before that, and you just start building a kill chain of how does this happen? The way 5-year-olds explore the world. They keep on asking why. That's basically what you're doing with building an attack tree. Everything that's not the doomsday scenario or that does not contribute to the doomsday scenario, you're just going to throw out. That's basically what you're doing here. One other advantage that comes with doomsday scenario setting, and this is when we build threat models at Torion, we tend to work with doomsday scenarios to scope our threat models for clients. Otherwise, we have a very hard time figuring out what is important, what's not important. We ask business owners, what are your 3 doomsday scenarios? And then we work back from there. An additional advantage is that impact scoring becomes very, very easy because you can start building a mathematical model of what, if you completely ignore likelihood, so when you're looking at a weighted graph, you're ignoring the weight of the edges, but you're just saying, okay, if this is certain to materialize into the next step, attack tree-wise, then you can start saying, okay, if you have a specific kind of a threat that is not directly linked to a doomsday scenario, but that is only linked to another threat that is directly linked to one doomsday scenario, then we say this is low impact. Makes it very easy to assess the impact dimension of your different types of threats. If you have a medium impact, then that means that it's a threat that directly leads to a doomsday scenario or that indirectly leads to more than one doomsday scenario. Then you call it a medium. You call it a high when it has a direct lead into one doomsday scenario and an indirect one to another one. And you call it critical if it has a direct connection to more than one doomsday scenario. This is a model. For some businesses, this is not a good model. So we sit together with our clients to say, okay, this is the basis we would start from. Does this make sense to you? All models are wrong. Some models are useful, just like analogies from the previous talk. This is just a model to simplify our world. We build models to simplify the world. That's the way a human brain works. So this is purely a qualitative approach to things, but it does bring you some advantages. And this is why doomsday scenario setting, for me as a professional threat modeler, makes a lot of sense to do it like that. More ways to reduce scope. Tackling the oldest technology first is also a popular approach, especially when you're working with legacy systems. You will see, you would be surprised at how recent this is. This is a picture of an ATM from 2018, still running Windows XP Pro. I think that's a brave move or a dumb move, depending on what your philosophy is. But that could be a thing that you're approaching your legacy estate from the standpoint of what have we had around the longest, where have we lost vendor support because the vendor simply doesn't exist anymore. I was working with a client a few weeks ago who had bought a very expensive, intelligent sunlight blinding system that could measure what is the amount of sunlight that's coming in and that would adjust its lighting based on that. Vendor goes bankrupt, system doesn't work anymore, and then they have to find a mechanic to kind of like connect the crank up to it. It's not really something you would want, but it does happen. Vendors go bankrupt. A bankrupt vendor is basically a disaster waiting to happen for a cybersecurity breach that no one can patch. So that's also an approach, tackling your oldest technology first. Another popular approach is excluding responsibilities of someone else. If I can't fix it, I'm not going to worry about it. I'm not going to say that that's the best approach to take, but it is a way of reducing your scope. If, for example, you're saying, I host everything in AWS, and I assume that AWS protects me from denial of service attacks. So I am going to completely outscope all threats that have to do with denial of service on the networking level. Of course, business logic-wise, you can still exploit a business logic flaw that puts your system in an infinite loop. AWS is not going to do anything about that. They can maybe help you look at resource consumption. That's very, very abnormal, but that's about all they can do. So if you can't fix it, why worry about it? That could be an approach that you could take, which in a lot of cases makes a lot of sense. Demanding your suppliers to give you their threat model, I don't think is an outlandish idea. What are you? I am your client. I am giving you money. What are you doing to protect what I am giving to you? I don't think that's too horrible to ask. At the same time, a lot of vendors are just pulling the hashtag trust me bro card and then kind of ignoring the problem until it becomes a problem. That's not really, it's not a very good way to approach this. Other ways of reducing scope in a threat model is only focusing on the external perimeter. Is a valid approach. So if you look at a system, you look at it from a walled garden or a moated castle type of a perspective, and then you're just going to say, okay, I have a system, all of the internals, I implicitly trust everything that's inside of my system. All my services are trusted, which is very counter to the idea of a zero-trust network architecture, but let's then try to pretend that that doesn't exist. And everything that externally connects to me, I am pulling in weather data from a weather API. I'm going to scrutinize that. I have human end users who are connecting to me with a mobile app. I'm going to threat model that. But once anyone would get remote code execution on one of my systems internally, I'm going to try to prevent that from happening, but when it does happen, I will accept that my whole system will fall down. That is a way of reducing scope. I can agree with the sentiment that attacks from the outside are more likely to happen, or they are at least the first thing that an attacker is going to try. With that, I always say, attackers are not exclusively on the outside because you employ people who can turn on you. There's a number of different ways how insider threat can become a problem. We trust our people is something I hear in almost every threat model, and to an extent you have to trust your own people. There's a lot that you can say about inherent trust in your employees, because it's not because they are trustworthy today that they are trustworthy tomorrow, and they might also not want to attack you, but they might be extorted into attacking you. This is something that happens more often than you think with these types of insider threats. Another way of reducing scope, thematic threat modeling sprints. So when you start looking at a system and threat modeling it, in every sprint where you threat model, you don't look at just the feature that is changing, but you're picking up the slack in regards to what kind of things are we going to focus on and what kind of things are we not going to focus on. So in the 6 properties of cybersecurity that you see over here, so you have the CIA triad, which most people are familiar with. Those are the primary 3 legs of cybersecurity. Secondarily, you have authentication, authorization, and accountability, or non-repudiation, as we sometimes call it. So I'm just going to say, in the next sprint, I'm just going to fix on these 3. And everything that has to do with the CIA triad, I'm not going to focus on. Those will deserve their own bespoke sprints. So I am looking at information disclosure threats in the next sprint, but nothing else. I am looking at integrity checking in the sprint after that, and I'm looking at nothing else. I am looking at availability of my systems in the sprint after that, and also nothing else. And then you just keep on repeating through these 4 pillars. That is also an approach that you can take to make your threat modeling efforts a little bit shorter. This one fits very neatly with the time boxing approach I explained in the beginning. So if you say, every sprint I will just spend 2 hours threat modeling, that rhymes very well with this approach, to kind of contain yourself to specific types of threats. I would advise you, if a conversation leads you to think about any of the other ones, don't ignore that. Just write it down, but don't keep on talking about it until it is the turn of that specific type of aspect of your system. Not reinventing the wheel, so when we start talking about the output of a threat model, there are a lot of things you can do when building reference architectures. So at some point in your organization, when you've built a few threat models, you will see that a lot of things keep on popping up. Creating a reference architecture makes that if a new system gets developed, you use the reference, you use the reference architecture that we set out that was deemed to be secure. Netflix has this kind of an internal program where they tell developers, if you use these security services, we will not harass you with any annoying questions. That's a way that you could do it. And then you work with the comply or explain principle. So this is an architecture that out of the box we've threat modeled. We will keep on updating the threat model of that specific building block. And when anything changes, we'll let you know. And we'll make sure that you can seamlessly transition when we change stuff. Maybe we will introduce a breaking change, but that's, in that sense, a reference architecture is also just a third-party dependency. It originates from within your organization, but in that sense, your architecture team or your security architecture team will supply you with a reference architecture that you can use out of the box in a very ideal world accompanied by unit tests and integration tests that you can just plug into your CI/CD pipelines. Using security patterns, that's kind of parallel or in overlap with the principle of a pre-threat modeled reference architecture, is where you have a combination of a specific problem you're trying to solve in the security sense and a specific solution that you're tacking onto that. That's what we call a security pattern. Some people call it a risk pattern, but they are basically the same thing. Those two terms are analogous to each other. So that is then how you can say, okay, you want to authenticate people. We are a Microsoft shop. We use Azure. Entra ID is your IDP of choice. Use that one. And then that's basically the overlap between a reference architecture and a security pattern, because your problem space is securely authenticating someone and having audit trailing and everything connected to it. Use Entra ID because this is an IDP that we use and trust, and this is how we're going to do stuff. I know that we have finished a little bit early, and I have done that on purpose because right now we still have 20 minutes for questions. So questions about the content of the presentation are more than welcome. Any question about threat modeling is also more than welcome. Anything that has nothing to do with threat modeling, I might not be able to speak to, but we can definitely talk more broadly about security after the talk. So this was it. What I had with slide content. So does anyone have any questions? I see 2 hands up. Can we get a microphone there? A person in the back was first to raise their hand.
Sure. So I have a question about some of the tooling that you've standardized or adopt when you're practicing threat modeling. Internally, it's something that I do manually and then I document after the fact. I'm curious if there's any tooling that you found useful just in general, and then secondarily, tooling that leverages LLMs or AI of some fashion. Have you found value in either of those 2 things?
Yes. And so I'm also going to explain what. So the tooling that exists on the market today, there are threat modeling tools. There are quite a lot of threat modeling tools. At Torion, we also keep an inventory of all the threat modeling tools. Threat modeling tools, however oddly it sounds, are not geared towards threat modelers. Threat modeling tools are made to help people who are not professional threat modelers to still do something with threat modeling. A lot of the commercially available tools are even geared towards software developers and architects who otherwise don't really have a lot of security knowledge, but to help them create a threat model by standardized questionnaires and then triaging the output. You can compare it a little bit to static analysis of code. So you just push all of your information in there, and then the tool, depending on answers to questions that you give, will come up with some kind of a threat, and then you have to triage that yourself. So that is what threat modeling tooling does. It automates that process for people who are not professional threat modelers. I, myself, and my colleagues, the tools we use are Draw.io to draw diagrams. We use Excel to do our threat analysis, and we use Word to write our reports. Those are the only 3 tools I use as a threat modeler. Your second question, to have you come across large language model assisted tooling. A lot of the tooling vendors now, not just in the threat modeling atmosphere, but everyone wants to put the AI stamp on their product nowadays. We are doing AI, and we are going to help you solve all of your problems by using AI. I think this is already the 10th time in humanity that we've been promised a technology that makes sure that we only have to work 3 days a week. It hasn't happened the last 9 times, so I also don't think it's going to happen this time. But introducing artificial intelligence into a threat modeling tool, for me, where the useful point there is to speed up the process of what you would otherwise lose a lot of time on manually. So translating architecture text into diagrams is something that LLMs are quite good at nowadays. So if you have an architecture that's purely built in text, you give that to a large language model that understands mermaid syntax, for example. You can ask it, this is how I want to see my mermaid diagrams built up. You give it a bunch of examples of, if you see this kind of a description, this is how I want to see it modeled. Then you give it a whole bunch of examples in a system prompt. Then you say, please draw a data flow diagram out of the following architecture. And then you put your whole architecture document in there. The results are pretty impressive, I must say. There are also initiatives like Eraser, for example, that is an AI-first diagramming piece of software where you can start from scratch just by typing, I have a mobile app and a single-page application as front ends that are talking to an API gateway in AWS, and they are connecting to 30 different microservices. Here are bullet points of what all of those microservices do. That thing will create a mermaid diagram out of that. So those advances I see as being useful to get you kick-started. Obviously, hallucinations. I always think it's a bit of a weird word to talk about a hallucination, because a hallucination is basically just an LLM lying to you or coming up with stuff. You will still have to check the output. And that is, I think, where it kind of goes wrong. We've had this paradigm a number of years ago when developers just blindly started copy-pasting stuff from Stack Overflow. And that is now also a bit of a shameful thing, to just say, yeah, in a stand-up meeting, yeah, I've been working on the patient intake service, and I was done a lot quicker than I thought I would be because I found a whole bunch of code on Stack Overflow and I just used that. That is a shameful thing to say today. At some point, we will hopefully get to the point where people would be ashamed to say, well, I just asked ChatGPT and it's generated a bunch of code for me and it looked good to me. So that is where LLMs, in my opinion, still need to be checked for accuracy. And I don't really think that we're going to get away from that very soon. So diagram generation and thinking about threats. So the creative process of thinking about threats is also something that LLMs can be very useful for. Again, because I only use Draw.io, Excel, and Word, I also run my local LLMs on my MacBook over here, and I have prompts that I use to, I give it a weakness, and a threat statement rolls out, and a potential mitigation rolls out as well. So I have prompts for that. One technique that I like to use there is recursive prompting. Who of you is familiar with recursive prompting? You have one hand up. Recursive prompting is a little bit like recursive programming, but in your system prompt, you're kind of describing an infinite while loop. So while you are processing what I gave you, you have to ask me questions that describe unclarities in what I gave you. And this is how you can keep on talking to a model. The way I do recursive prompting is basically telling the LLM in my system prompts, so long as you can still ask interesting questions, ask me those questions, I will answer those questions, and I will respond with the letter A at the end if I want you to repeat this process, or I will type the letter B if I want you to generate the output. And this is how I get quite good results with that kind of a recursive prompt. So those are two of the areas where I tend to use LLMs. For system description parsing, I do tend to do that locally. I work with thusly strong non-disclosure agreements that I cannot justify uploading a client's systems into ChatGPT. But that's, if your company is already using a specific LLM broker for something, then use that. That's basically my takeaway on that. Is that an answer to your question?
Yeah, that's great.
Okay. We had another question here up front. Do we have a microphone?
Interesting. I recognize some of those techniques. I'm really focused on the outside world more, so I would look at the external entities, and the third parties I think are incredibly risky these days. And
Makes sense.
You knew that from what we did yesterday.
Supply chain is an increasingly popular problem
But also
nowadays.
reliance on, particularly when you're doing systems which have multiple contractors coming together, actually that's the risk as well, because we're not all the same.
No.
The question I've got is, I've done a threat model, I've got a shed load of issues, how do I prioritize which issues I need to fix? Because again,
that's a great question.
Again, I'm going to be time boxed as well, and we all recognise as risks. So how do we identify which of those issues, guaranteed that we're only going to find a limited number based on the time, which ones do we then start working on next?
Yeah. Risk prioritization is obviously inherent to threat modeling. Once you find a bunch of stuff, what are we going to do about it? Answering that question is something that you're going to have to answer that question at some point. Just looking at risk severity would be a knee-jerk reaction, but that's not always your smartest move. If you have output from a penetration test, for example, let's say that you have one critical finding, 2 highs, and 2 mediums, and 5 lows. Let's put it like that. The one critical issue, depending on the time to fix, I would put that in as a dimension parameter as well. Time to fix is a very, very important metric here. If you can fix something really fast, I don't really care about the criticality. Just fix it. Because it's not because you have a low severity issue. Fixing it immediately can cut a kill chain, because some kill chains are built out of, like most kill chains are built out of different links. One of those links can be a very low severity issue that you might think, well, it's low severity, we don't need to fix it immediately. My stance is, if you can fix it quickly, do it, regardless of risk severity. So try to fix, just work with numbers. The number of issues you can fix, I think, is to be prioritized over the severity of issues that need to be fixed. So time to fix, also cost and effort to fix, obviously. And time and money start overlapping there a little bit, because you have to pay your people to actually do it, and when they're doing something, there's an opportunity cost of them not doing something else. So time and cost to fix, absolutely. Also, working in a staged approach helps. So if you have a critical, if with relatively small effort you can bring a critical down to a medium, and then over the next 6 months we're going to make sure that that medium disappears entirely. So that kind of staggered approach can also help. Is that an answer to your question?
Yeah, and I think there's also, and we didn't touch this about, there are templates like NIST give you a whole load of controls that you could select. And as you say, okay, depending on, okay, there's an issue with access control. As you say, you might say, okay, let's just put a strong password policy first before we go to MFA, before we go to whatever.
Yeah.
So I think, as he says, try and close the risk down.
Yeah. So the question for the recording, because we didn't have a microphone here anymore, so the question was, there are a lot of control frameworks that you can use, so you might as well pick the ones that kind of like reduce the temperature of the fire and then slowly start putting it out. Yeah, no, absolutely, yeah. Any more questions? We still have 6 minutes. And if there are no more questions, we have a break that is 6 minutes longer. I am also fine with that. No more hands up? Then this was my time. Thank you very much. And if you still have more questions, I'll be around before noon. I'm leaving after lunch, but if you still have any questions, please chat me up. It was very nice having you. Thank you.